Well, hello and welcome back. So I'm going to talk about how to draw depth auxiliary views. They're kind of like the introduction type of auxiliary views, pretty basic, but it's usually a hard concept to wrap your head around. And I do have an example here from the technical drawing book on page 370. If you want to look though, so you have like this 3D model shape here, and in order to keep up with what you're drawing with your auxiliary view, it labels each point on each of the vertexes. So, say you have your normal, front view, and you can have either a top or side view. You can go and create this auxiliary view, and the intention here. So when you're looking at this face here, if you look at it in any view besides an auxiliary view, that face will not be true to size. So you could measure from 1 to 8, and that would be the length here, 7, 8. But like other than that, that's the only info you can actually use truly. So the whole point of an auxiliary view is to recreate that oblique face in a true to size fashion. And then because you're doing that, everything outside of that true to size face is actually not true to size. So if I were to measure 2, 3, like in this case, wherever that is, right here, you can notice it's actually truncating here. It's getting smaller. So auxiliary views are basically just used for that niche case where you're trying to, capture some design details that are not true to size, but you want them to be true to size. So, so let's talk about the actual principle behind it. So the idea is, so you have your two views, and a lot of the ones in my classes are side views, but the same principle applies here. You would offset from that oblique face, a certain amount, just a chosen value. And basically it has to be, without saying it makes sense, it's 180 degrees from this line to, we'll say, this line. So, when you try to dimension it, there should be no value pop up. The easiest way to start these views is usually literally just to do an offset command. So then you're using either your side or your top view to produce a lot of this. So like in this case, if you notice, you have a depth dimension here. So basically what happens is you measure that depth, you offset from that original offset a depth value, and you have kind of like a rough box of what it looks like. And then, if needed, you can offset like D1 in this case, and they don't really show it too well in the actual drawing, but that's what they're trying to say. Like you would have another line that goes through here. So then you have this edge replicated, this edge, and this edge. And that's all the information you'd use from the depth view. So then you would move on, and this is where the projection begins. So there's a lot of ways to do this, but the one that I find easiest is, since you already did an offset, you know that over here you had 1 and 1, and they're in line with each other still. So you can just draw a line connecting a dot. And then usually I'll just extend that line out, and I'll copy it, and then you just paste it on each point that you see through here. Now they didn't do 3, but technically 3 is 8, which is why they didn't do it. But yeah. So pretty straightforward there, and then from there, that's where you're kind of having to do a little bit of guesswork. And in my classes, I give a DWF as a reference for you to look and see what you're missing. But you just basically have to, from there, trim and connect the dots. The hard part about that is you have to use a lot of logic and reasoning. So you end up having to think about what edge is what, and that's what the labeling here is for. So when you're looking at, say, the ISO view, you can see that 1 and 2 are this edge and 7 and 8 is this edge, but we know that for a period of time 1 and 2 and 7 and 8 are collinear. So you would basically have to say, well, okay, here's this part, so clearly that connects there, and go through and try to complete the actual edges. So you try to connect each edge, and then you're trying to close out faces. So it takes like a very methodical approach to do these, but I'm going to show it in a drawing form. Alright, so I'm just going to start drawing the exercise 9.6, problem 1. And we'll just start at like 60, 60. And then once I've got it drawn here, we'll talk about kind of how to do it. I mean, I've talked about a general concept, but I'll show some tricks to help a little bit. Alright, and then I will do the dimension values were given. project this edge over. Tell you what, I'm not a big fan of this new trim with the whole line concept. Still growing on me, but yeah, not great. Alright, and then I'm just going to dimension these since we'll be using the depth values for our auxiliary view. Okay, and it may be a little hard to see. It's kind of hard to see for me, but we'll work with it. So, there's different ways to do an offset. Whenever I'm not sure where I want it, a lot of times I'll do this. I'll just do offset enter, and it lets you pick a value. So I'm going to just move it, and I think I want it to be about 60, so that I can type it in. Alright, so this is our auxiliary face. This is the width of it. It's a good start. So now from here, this is the first thing I usually do so I don't mess it up and have to do it later. But I will go ahead and draw a line connecting this edge to this edge. And I'm going to change it to a projection layer, which is really hard to see, but we'll work with it. And then what I'm going to do is I'm going to copy this same one, grabbing that point, and I'm just going to snap it on every point. Now, I would imagine it actually is really hard to see, so let's put this on a center layer. I took off the center line type just in case. So now I'm just going to go ahead and we'll do like a random line so I can extend it out past. So I'm just going to extend out our original edge here, both directions. Extend out all of our projection lines. Okay, so now we can go back and trim. Now, it goes without saying, you know, your auxiliary view is only going to extend as far as the furthest edge. So, you know, this point and this point will be the end of our part view. So I can delete these now. And then to get our general box shape, we're going to do an offset value of 45, which is the overall width. And then we can go ahead and connect the dots here. And this is going to be, you know, like the general shape of this part. Now, so this is where you're going to start having to think about things in a dynamic way. So we know that we have the 22 from this edge, and this edge happens to be here, so I can offset it this way. Okay. And then we know that, you know, so basically that's just for this top portion. So the 22 only matters until this line. After that, you don't need it. So I'm going to go ahead and try to complete a face while we're sitting here. So I'm going to trim this out. And then I'm actually going to do, this is a really helpful command. I use it a lot whenever I'm doing these, a break at point. You select the object, you choose a spot, and it breaks it. So now I can make this an object line. Alright, so just like that, we've got our face. It's this length and this width. So now we're just going to try to keep working towards the next points here. Okay, so when you're looking at this auxiliary view, I'm sure you're probably thinking like, oh yeah, connect the line to this corner, because you know that's what it does here. But you have to remember this is an auxiliary view, so that's actually not where you would connect it. When you're looking at it, so if you were to look at this top point, which is here in the side view, it actually connects to this point here. So you're not trying to connect it all the way through. It's truly two line segments. So you have to connect this point to this point, then this point to this point. So what we're going to do is extend this line out. And, you know, there's a couple of different ways to go about this. I'm actually going to undo that extend. So what a lot of people would advise doing is measuring the width of this and using that value to offset from here. But that's frowned upon because you're going to have value loss. You know, this is it's not an even number. This is a round off number, and whatever you do, you're going to end up losing value. So the best thing to do is to copy it, choose a base point. We're going to paste it over here, and then we'll rotate it. And then let's see if we can't use some kind of projection here. There we go. So now we know that if I were to dimension this, oops, with certainty, we know that these two values share the same round off. So, you know, you're not losing any data by copying. And then we did talk about how this point to here would be the edge. Conversely, you know, it's also from here to here, but it's not as clear. Usually the side view is going to give you most of your info. And then of course we talked about from this point to this point, you would connect the dot. So you're simply doing this number right here. So now it's starting to look like something. And for some people, they like to delete these lines, but I really feel like it helps to verify your accuracy. So now that we've got 3 faces completed, we just need to complete the rest of it. You know, that involves doing the back side, basically. So we know that the bottom edge is here. And naturally, you can assume the bottom edge extends the full length of the part, because you can see it there, 45. So we can extend that. Okay, and I'm going to do another split at point, break it point. Change this to a hidden line since we have to be able to see through the part to see it. Now, you might think, oh man, I'm done, but you're actually not. Okay, so let's keep thinking about this. So we know that this whole side over here is slanted, okay? So we're missing an edge. What we're looking for is this line, but on the back side. So essentially, it would be the line that goes straight from this point up here to this point on the back of the model. So we need to think, here's that point, here's that point. So what we're connecting is the right side endpoint, which is here of that edge, and then the end of the part, so here. So actually, this whole corner, boy, I hate the new trim, does not exist. So just like that, you can go back and check. You've got your top face, your oblique face, you've got this face here, you've got your side, your other side is just an edge, and then you have the bottom face. So this would actually be how you would go about it. You know, this is the complete product, and it varies. The only thing I would mention is if it's not a basic part like this and you have a circle in one of these views, it's probably going to be an ellipse in the auxiliary view, because you know, things are not true to size, so it tends to elongate or truncate. But that's the general premise. And then, you know, if you're doing my classes, when you do these, make sure you are dimensioning, you know, all views, auxiliary and regular. And I would advise keeping these projection layers if you want. You know, it helps me to check it. But it's also, you know, kind of nice to verify things for yourself. But I also do like to have it on a black layer, but I'm sure that's really hard to see for you YouTubers. So, but that's going to be it. If anybody needs anything, just give me a holler. Thanks.